In this video, we will discuss about what are the coherent waves are, how we can check whether two waves are coherent or not coherent. So there are two qualities which we need to look into. So what are those two qualities? That we will learn in this video. What we will do, we will take two waves and check for coherency, whether they are coherent or not. So these are the two waves, red one, and below I have drawn the yellow one. So what is the consistency here? Why they are coherent? If I say so, that these two waves are coherent, how we will check it? So let us observe these waves closely. So first thing what I can measure is the trough to trough distance, or the wavelength of both the waves is same. That is the first quality of coherent waves. Their wavelengths are equal. So okay, that is very easy to measure. There is one more thing, which is constant or consistent from where the coherent word is coming. What is that? So if I'll just superimpose this wave on top of the one, then you'll see they are completely in the phase. Crest is meeting the crest perfectly and trough is meeting the trough perfectly. So what we can say here? We can say that all the corresponding particles are in phase, or completely in phase in this case. So let us write down what we have learned. The first quality is the wave should have same wavelength, and in this case the difference in phase is 0, and this is consistent throughout. It is not like the phase difference is changing as we are moving through the wave. It is same, it is constant, it is consistent, or it is coherent. Let us look on this point in more detail. When I say delta phi is equal to 0, what does that mean? So we'll check this point and corresponding this point. They are in the same phase. This point and this point, same phase. You check any point on this wave and you can move along in this wave, you will find that every corresponding particle is doing the same thing. One is going up, then other is also going up. One is coming down, then other is also coming down. Their phases are exactly the same. So there is no difference in phase. Their delta phi is 0. And it is not true only for this circled wave. If you check the next wave, it is consistent, it is constant, or these waves are coherent. So here the delta phi, or difference in phase, was 0. They were completely in phase, but they can be out of phase also. So let us first see the two coherent waves which are pi by 2 apart, or we can say they are out of phase by pi by 2. This is our pi by 2, half of pi. So what we will do, we will make this wave out of phase. So let me shift it to the left side. So now that pi by 2 is out of phase, now compare the remaining wave with each other. Now they are in out of phase. Do you know by how much? By 0? No. Now the delta phi is pi by 2. They are not in phase now. They are out of phase. But the most important point here is that their delta phi difference in phase is consistent, coherent, constant. If we will merge these waves just like this as we were doing in the last case, so you will clearly see their phase difference of pi by 2 or 90 degree. But this is consistent. It is remaining same for the entire wave. It is not only for one wavelength. We can check it. We can take different points, say these 2 points. The phase difference is 90°. What about these points? Again, consistent, same. The delta phi is constant everywhere in the wave. So these waves are coherent. So the second point is more we need to focus on the consistency of delta phi. It should be the same for both the waves, then we will say they are coherent. Now this is the entire pi. So I will make this wave out of phase by pi. So let me shift that entire pi out of this picture, and if now I merge these waves, what you are able to see? Crest is meeting with the troughs. So they will cancel out each other. But here, what is the delta phi? Or the difference in phase is pi. And it is consistent everywhere for the entire wave. Take any point, this point. So one wave has completed 2 pi and the other one only pi. The difference is pi. The delta phi is pi. And it will be same for every point if you calculate. These waves also are coherent. So there are two qualities now which we can see of coherency of waves. So let us answer the question. Which will be the coherent waves? There are two qualities. First is their wavelength should be coherent or same or constant, fixed. And also the difference in phase is also should be constant. Whatever it will be. It can be 0, it can be pi by 2, it can be pi, but it should be throughout constant or coherent. Thomas Young in his experiment of double slit used coherent waves. That is why he was able to see the interferences very clearly. In the Young's double slit experiment, we have talked about constructive and destructive interference. So if we add these two lines, pair of lines, we will get different results. On the left side, they are in complete phase, or I can say the delta phi here is 0, or it can be 2 pi. It is the same thing. So if we say that the delta phi is 0, they are in complete phase, they will do constructive interference. And destructive if they have a difference of pi, which these two on the rights are showing. So if we'll superimpose, we will get the results. So the crest is superimposing on crest and trough on trough. So we will get the brightness. The amplitude or height of the wave will increase, which we can just tweak it like that. So the resulting wave is shown in the white one. So this will be the result when these waves with the constant phase difference of 0 will meet. But in this one, if you just superimpose it, you will see the crest of one wave is meeting the trough of another wave. So what will happen? Will you get light? No, they will cancel it out. The trough will cancel out completely the trough. So we will see the flat line, or in light terms we can say we'll not able to see the light. We will see the dark spots. So here that's why no light is coming, completely dark. And on the left we will see the brightness.